Today we'll be doing experiment 14. This is an example of Friedel-Crafts Acylation. The first thing that you should do when you come into lab today is to turn on your sand bath as high as it will go and begin preparing your hot water bath, since that takes the longest time to heat up and get to the temperature you need it for the reaction conditions. Beginning with phthalic anhydride, you're going to react it with toluene. The experiment says dry toluene. That just means that there's no moisture that's contained in the toluene, along with aluminum chloride. Aluminum chloride is a corrosive reagent, so you're going to want to be careful with that. Toluene is toxic. So the mechanism is as follows. The carbonyl oxygen of phthalic anhydride reacts with aluminum chloride, complexing to the oxygen. And then as the electrons from the other carbonyl collapse down, breaks open the ring to form an acylium ion. The pi electrons of toluene come in, attack the acylium ion to form a sigma complex. And then chloride picks off a proton, regenerating aromaticity. And at this point, when you quench it with the acid, you should see a white solid that's representative of this intermediate. After protonation with your dilute HCl solution, you form the carboxylic acid product. The biggest problem that we face in this reaction is during the workup, there tends to be an emulsion where the aqueous layer and the organic layer fail to separate. One of the things that you can do to prevent this from occurring is on your workup, rather than quenching it with ice, we're going to quench it with 4 milliliters of 3 molar HCl. And you're going to heat that in your hot water bath for about 5 minutes. This will help break up the aluminum salts and help for making a better extraction process for you. Some experimental notes then. It's going to be important that you maintain dry conditions. Moisture will damage the phthalic anhydride, will react to phthalic anhydride as well as aluminum chloride. So we want to make sure that the reaction vessel is kept as dry as we can. And so what we're going to do is we're going to flame dry our glassware prior to use rather than putting it in the oven. Flame drying the glassware is more effective than oven drying it. Okay, and then just another alteration in the procedure. We're going to quench it with the HCl rather than ice. You're going to heat that for about 5 minutes. And then during the extraction process, the quantities of the ether and the sodium chloride saturated acid solution do not need to be exact. So just approximate values. Okay, so we'll go ahead and proceed with the reaction. We'll begin by drying our glassware in the hood. So with flaming the glassware, just going to use a pair of forceps to hold it, and then you just begin at the back side. And as you heat it, you can see the condensation rising up the glassware. And I'm just going to kind of persuade it up the neck of the flask. Once again, you want to make sure that there's no flammables in the area whenever you work with an open flame. Okay. Then I'm just going to put it in a beaker to cool. And I'll just heat my spatula the same way. Okay. And I'll let those cool down and we'll be ready to go. I've gone ahead and I've measured out all the reagents for this experiment. With the phthalic anhydride and the aluminum chloride, I measured them into a boat like this, and I've transferred it into the round bottom flask. The toluene, I took a tear of the syringe, then I measured the toluene into the syringe and then transferred it directly into my round bottom flask rather than the 10 by 100 milliliter millimeter reaction tubes. Okay, now I'm going to fit it with the septum. The way this works is you set it on top, then you grab one edge of it, and you pull it over the top. Okay, so the septum folds over the lip of the round bottom flask in this manner. Okay, my hot water bath is ready to go. I'm going to set up my gas trap. So just perforate the septum with the 2-edged needle. Make sure that the tubing that hooks up to your gas trap is not blocked. We don't want to heat a closed system. And careful not to stick yourself as you put the other end into the capillary tube. And now I'm just going to heat it for 20 minutes, and then we'll catch up with you later on in the reaction. When you set up your hot water bath, it would be useful to put only about 100 milliliters of water in your beaker. If you put too much water, it's going to take a long time to heat that much. While this is heating for the 20 minutes, this would be a good time to put your HCl sodium chloride solution together for the extraction and to prepare for the workup stage. Okay, so it's been 20 minutes of reaction time. This is what the reaction looks like after the 20 minutes. It's slightly kind of a orangish brown color, and it's very thick and crusty. So in quenching the reaction, I'm just going to add the HCl solution that we talked about before. This is 4 milliliters of the 3 molar HCl, and I'm just going to put it in here. And I'm just going to let it sit in the reaction bath for 5 more minutes to help break up those aluminum chloride salts. Okay, so I've heated the workup for about 5 minutes in the hot water bath. It looks like most of the aluminum chloride salts have broken up. It's cloudy, and so I've taken it out of the hot water bath and I've cooled it in an ice bath for a few minutes. And now I'm going to do the extraction process. So I'm going to transfer it to a centrifuge tube. And I'm going to extract it with some ether. This is my quantity of ether that I've collected. And each one of these, this bulb is equivalent to about a milliliter. And so I'm just going to add about 1.5 here. And I'll cap it and shake it up. Vent it carefully. Repeat this a few times. Okay, and to help it separate, you can kind of rock it back and forth. And the aqueous layer is going to be on the bottom, and the organic layer is on top. And so it's nice we have a clear-cut barrier between the aqueous and the organic. And so I'm going to take off the organic layer. And set it in a beaker. Okay, I'm going to add about that much ether again. Shake it up. Turn it to the side a little bit. Rock it back and forth. Okay, and so they've separated out. Okay, and then one more time. Probably a good idea to vent it away from you. Once again, rock it back and forth. And collect the organic layer. It's okay if we get a little bit of the water with it. We're going to wash the organic layer with saturated sodium chloride in just a minute. Okay, so what remains in the centrifuge tube is just the acid solution with aluminum salts, and we'll just set it in a beaker and put it aside. You might want to label the beaker just to make sure that you don't mix up your layers. So I'll grab my organic layer, put it back in the centrifuge tube. And then using the saturated sodium chloride solution, I'll add about a milliliter or two of that. The idea behind this is the sodium chloride solution is highly polar, and so it will help pull out the moisture that's been absorbed into the ether layer. It's a preliminary drying step. Okay. Once again, let's shake it up. Vent. And then this time let's draw out the aqueous layer and combine it with the other one. Okay, so what's left is just the organic. I'll put it back into the same vessel. Actually, I'll use a drier 10 milliliter beaker. Place it in here. And now I'll use some sodium and hydrosodium sulfate to further dry it. When it's dry, it flows freely. And so I'm just going to put a small spatula full of it in here. Let it sit. I'm just going to decant the solution off of the sodium sulfate, trying to leave the salt behind. Put this in a 10 milliliter beaker. Okay, and then I'm going to add a boiling chip. And then I need to go back and boil off most of this ether in the hood. I have quite a quantity of ether, and just using some hot water, I'm going to boil off most all of that ether. Make sure you're using a hood that has good ventilation. Ether has a very low boiling point. It's highly flammable. So I'm going to boil it down to about half a milliliter, or to about a milliliter. Okay, so it's already starting to turn cloudy. I'm going to take my boiling chip out. With my experiment, the crystals have already started to form. But if you haven't seen crystals yet, you can add a little bit of Lagroin, which is hexane solution. This is it's a nonpolar substance that helps to push the polar carboxylic acid product out of solution. And then to further drive our crystals out, we'll just put it in an ice bath for a few minutes to cool. Okay, so I have quite a few crystals, and now I'll collect those crystals by way of suction filtration. So using your small suction Erlenmeyer flask, your filter flask, and a Hirsch funnel, okay, this one doesn't seem to have any suction. So let's try a different one here. You can wash your crystals with some of the Lagroyne hexane solution. And then when you remove the filter, remove the pressure before turning off the water. If you turn off the water before you remove the suction, you have a chance of the water back sucking into your vessel. And so here's my crystals, here and here. You can either put them in the oven to dry, or if your lab isn't due for a week or two, then you can put it in your drawer to dry over time, get a mass and a melting point next week.